All right, so this is 4.3 notes. We're going to learn about the 6 trig functions according to right triangles. So we already know 3 trig functions with a right triangle. So if we have an angle theta, we can find the sine, cosine, and tangent using COA. So sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over adjacent. So this is Geometry 101. Everybody in here should know this. We have 3 more trig functions now. So we have cosecant, which is the reciprocal of sine. So this is now hypotenuse over opposite. Our secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So it's just the reciprocals of the one that they pair with. One important thing to note on the next slide is theta has to be greater than 0 and less than 90. We can never find the sine, cosine, tangent, cosecant, secant, cotangent of 0 or 90 with our right triangles. So the only angle we would have in our right triangle that is either 0 or 90 would be 90. We can never use this as our theta. So the right angle is always just our right angle, can't use that as our theta. So it's either going to be this angle or this angle, one of the other 2 acute angles in our triangle. These are 6 trig functions. So I just went over them on the first page. Sine, cosine, tangent, cosecant, secant, cotangent. And this brings us to our first example. So here we need to find our 6 trig functions according to this triangle. So we have theta here. So we need to find sine, cosine, tangent. I'll put them down here. So we have cosecant, secant, and cotangent. First things first, we need to find what our hypotenuse is. So we have a leg of 3 and a leg of 4. So what can we do to find our hypotenuse?
Pythagorean theorem.
Pythagorean theorem. So a squared plus b squared is equal to c squared. So we have 3 squared plus 4 squared is equal to our hypotenuse squared, which we can just call x for now. So this would be 9 plus 16 is equal to x squared. 9 plus 16 is 25. Take the square root of both sides. So what's our hypotenuse? 5. So our hypotenuse is 5. So sine is opposite over hypotenuse. What's opposite of theta? 4, and what's our hypotenuse?
4 over 5.
So sine of theta is 4 over 5. Cosine is adjacent over hypotenuse. So what would our cosine of theta be?
3 over 5.
3 over 5. What would our tangent of theta be? Opposite over adjacent?
4 over 3.
4 over 3. And then cosecant, we can just flip our sine. So what would cosecant be? 5 over 4. What would our secant be? 5 over 3. So we just flip the cosine. And then our cotangent? 3 over 4. Not too hard? Bless you. All right, the next slide was just for you to fill all the 6 trig functions in, but it refers to the slide before. And now we have 2 more examples on the next one. So let's take a look at number 1. So our theta is this angle here. So what would our sine of theta be? So sine is opposite over hypotenuse. So 5 over square root 6. What's wrong with this 5 over square root 6?
You can't have a square root as the denominator.
So how do we get rid of that square root in the denominator?
You multiply by square root 6. Yeah, by square root.
We multiply the top and bottom by square root 6. So square root 6 times square root 6. So what does the top become?
5 times square root of 6 over 6.
5 times square root 6 over 6. So this is our answer for sine. Now cosine. Cosine is adjacent over hypotenuse. So what's adjacent to theta? 2. So 2 over square root 6. What's wrong with this one? We have same things. So we multiply the top and the bottom by square root 6. So we have 2 square root 6 over square root over 6. Can we simplify this?
Yes.
Yes. What does it simplify to?
Square root 6 over 3.
Square root 6 over 3. All right, tangent. Tangent is opposite over adjacent. So what would our opposite over adjacent be? 5 over 2. That one's perfect. Don't need to change it. Now our cosecant. What would our cosecant be? We could just flip this and have it 6 over 5 square root 6, but we would need to rationalize it again because we would have a square root in the denominator. Or we could just take what we started with, which was 5 over square root 6, and flip that. So we would get square root 6 over 5. And then what about secant? Perfect, square root 6 over 2. And then cotangent? 2 over 5. Any questions so far? I know we're kind of zooming through this, but it's not too complicated. For number 2, we need to switch the hypotenuse to be 11 and the leg to be 10, just because your hypotenuse has to be the longest side. So just to start off with, the hypotenuse is 11 and the other leg is 10. All right, so our theta's up here now. What would our sine of theta be? Perfect, opposite over hypotenuse, so 10 over 11. What about our cosine of theta? Square root 5 over 11. What about our tangent? Ten over square root 5, but we need to multiply the top and bottom by square root 5. So we get 10 square root 5 over 5. Can we simplify this? To what?
2 square root 5.
2 square root 5. All right, cosecant. What would our cosecant be? 11 over 10. What's our secant? (11 over square root 5). Got to multiply the top and the bottom by square root 5. So 11 square root 5 over 5. Can we simplify this?
No.
Nope. So that's our answer. And then cotangent. instead of doing 1 over 2 square root 5, what can we flip? So we can just flip what we started with, so it would be square root 5 over 10. So we could always just flip our answer for tangent, but then we would have to rationalize that and get the square root out of the denominator, or we could just flip what we started with. Even though there's a square root in the denominator, but we flip it so it becomes the numerator. All right. Next slide. So for these, it gives us one of our trig functions. We have to find the 5 other ones, and we need to draw the triangle in order to do that. So what is cosine? Adjacent over hypotenuse. So in our triangle, if this is theta, adjacent is 5, and our hypotenuse is 8. So next to theta would be 5, and our hypotenuse is 8. How do we find our missing side? Pythagorean Theorem. So 5 squared plus x squared is equal to 8 squared. Everybody sees why I did 8 squared as the c, because that's the hypotenuse? Okay. So 5 squared is 25, plus x squared is equal to 8 squared, which is 64. Subtract 25 on both sides. So x squared is equal to what? 39. And then take the square root. So x is equal to square root of 39. Can we simplify the square root of 39? No. So just the square root of 39. All right, so now we need to find sine. We have cosine, which was given, so tangent, cosecant, let's do secant, then cotangent. So what would our sine be? Sine is opposite over hypotenuse. So what's opposite to our theta here?
Square root of 39 over 8.
Square root of 39 over 8. Do we need to simplify that? Nope, it's already simplified. What would our tangent of theta be?
8 over 5.
It's opposite over adjacent. So what's opposite of theta?
9 over 5.
Square root of 39 over 5. What is our cosecant of theta? So cosecant would be hypotenuse over opposite, because it's the flip of the sine. So what would it be? 8 over square root 39. We need to multiply the top and the bottom by square root 39 to get rid of our square root in the denominator. So this would be 8 times square root 39 over 39. Sorry, my Apple Pencil is just like not cooperating today. So I have to use my finger. My nails are too long for my handwriting to be good, so I apologize. All right, secant. What would our secant of theta be? 8 over 5. So So remember, our cosine was given to us up here, so we just flipped that. And then what's our cotangent?
5 over square root of 39.
5 over square root 39. Multiply the top and the bottom by square root 39. So 5 square root 39 over 39. Any questions on that one? All right, let's look at number 4. We have the cotangent of theta is equal to 7. So let's draw our triangle. Let's say theta is down here. What is cotangent? Perfect. If tangent is opposite over adjacent, that means cotangent is adjacent over opposite. So adjacent is 7. What would our opposite be?
1.
1. Perfect. So this is 7 over 1. And how do we find our hypotenuse? Pythagorean Theorem. So 7 squared plus 1 squared is equal to x squared. So 49 plus 1 is equal to x squared. 50 is equal to x squared. So the square root of 50. Can we simplify the square root of 50? Yes. What does it simplify to? Let's see. 50 breaks down into 25 and 2. 25 can come out as a 5. So 5 square root 2. Okay. So now we need to find sine of theta, cosine theta, tangent, cosecant of theta, secant of theta, and we already have cotangent. So what would our sine be?
One over 5 times square root of 2.
1 over 5 times the square root of 2. So how would we rationalize this? What do we need to multiply to the top and the bottom? Square root 2.
The denominator.
Just square root 2, because that square root 2, we'll get rid of the square root 2 in the bottom. So what do we get on top? Square root 2, and then what do we get on the bottom? We have 5 square root 2 times square root 2. 10. Perfect, because the 2 square root 2's become a 2, and 2 times 5 is 10. All right, now cosine. Cosine is adjacent over hypotenuse. So what's our adjacent and what's our hypotenuse? 7 over 5 square root 2. So we need to do the same thing to get rid of that square root 2 in the bottom. So multiply the top and the bottom by square root 2. What do we get on top?
7 square root 2.
7 square root 2. What do we get on the bottom?
Would it be 10?
10. Okay, tangent. Perfect, 1 over 7. What would our cosecant be? So 5 square root 2 over 1, which would just be 5 square root 2. And then our secant? 5 square root 2 over 7. All right, any questions from this page? Okay, so on the next page, we have sine, cosines, and tangent of our special angles. So in geometry, we learned our special right triangles are 30, 60, 90, and 45, 45, 90. So the sine of 30 is always going to be 1/2. The cosine of 30 will always be square root 3 over 2. So these are just our special trig functions for special right triangles. Okay, on the next slide. In example 8, you are given the angle of elevation, so that's on the next slide, which represents the angle from the horizontal upward to the object. So elevation goes up, angle of depression goes down. So if you're the person standing here, angle of elevation would be the angle if you're looking up. If you're the person here, if you're looking down, that would be our angle of depression. So the next couple problems are going to be word problems, so just keep in mind angle of elevation goes up, angle of depression would be looking down. Okay, so a surveyor is standing 50 feet from the base of a large tree. So we have a surveyor here and a large tree here. And they're 50 feet apart. The surveyor measures the angle of elevation to the top of the tree as 71.5. So from the person, our angle of elevation is 71.5. How tall is the tree? So this is our right triangle here. So we're looking for this x. We're looking for the height of the tree. So we need to use our trig function to help us find x. So if this 71.5 is theta, x is adjacent, opposite, or hypotenuse? X is opposite, and 50 is adjacent. So which trig function uses opposite and adjacent? Tangent. So we could say our tangent of theta, which our theta is 71.5, is equal to opposite, which is x, over adjacent, which is 50. And now we solve for x. So we would just put tangent of 71.5 in our calculator. So 2.988 is equal to x over 50. How do we solve for x? Multiply both sides by 50. So it'll cancel out there. And we have 50 times 2.988. What do we get? What did you get? 149.434. Everybody agrees? What unit would this be? Feet. Perfect. So this is the height of our tree. Okay, a large apartment building in New York City stands 135 feet tall. So this is 135. The angle of elevation measured from the base of a fire hydrant on the sidewalk is 37 degrees. So our angle of elevation goes up, and this is 37 degrees. How far is the fire hydrant from the base of the building? So we're looking for the distance from the building to the fire hydrant, so that would be our x. So what formula would we have to set up here to find what x is?
Opposite over adjacent.
Opposite over adjacent. So opposite over adjacent would be sine, cosine, tangent, cotangent. Which one? Tangent. So tangent of 37 is equal to opposite, which is 135, over x. So what do we need to do first to solve? So what's the tangent of 37? 0.753 is equal to 135 over x. What do we do next? We don't multiply it by 135 because that 135 is on the top. So we multiplied it before because that was dividing x, but now it's not. So what can we do?
You'd multiply 1 over 135 on both sides, which is basically just like dividing 135 from 0.753.
Perfect. We multiply 1 over 135 on both sides. So we're just dividing 135. So this cancels out. But then we're left with 1 over x here. Right? Yeah. So let's try something different. So we could cross multiply. That way we can get our x to be on top. So we would have 0.753 times x. So I'm just cross multiplying. And then this would be 1 times 135. Now how do I solve for x? Divide by 0.753. So what do we get for x? $179.282. And what unit would that be?